All right, I am back for week 10, video number 3, the last one for the week. And this is U substitution, which is just more integration. So there's 3 types, and we're just going to go through one of each. The first is where they already tell you what U should be. So a lot of times you have to figure that out, but in a third of the problems, they're just going to go ahead and tell you what they want it to be. So step 1 is just to take that and do a regular derivative. So du, the derivative of a constant is just 0, and the derivative of negative 8x is just negative 8, and then dx. And then we've got to look up here and see what we've got, because we basically have to account for everything. And so I have to be able to account for this and this, or else I've got to do some fixing. So I can account for this right here, so that's going to turn into a u. But I don't really have any place for this negative 8 to go, because there's no negative 8 to go with my dx. So what I basically have to do is move it to the other side. So I'm just going to put a negative 1/8 over here, du, because now I have that dx by itself, which is what I have here as a dx by itself. So I've got the 17 minus 8x, and I've got just the dx. And so now I'm good to do my substitution. So I'd have the integral of u to the negative 3, and then just my dx turns into du, and then you usually just kind of put that negative 1/8 out to kind of just go along for the ride. Okay, and then we're just going to do regular integration. And so remember, the rule is that you increase the power by 1 and then divide by that new exponent. So I'm just going to keep that negative 1/8, and then u, and then increase that power by 1, and then divide by that new exponent. And then we're going to rewrite it using this substituted back in. And so I would probably simplify this. So a negative 1/8 divided by a negative 2 is a positive 1/16. And then since that's a negative exponent, I would probably put that down too. So I'm probably just going to write this as 1 over, and then 16. And then remember that u is 17 minus 8x. And then since it was a negative 2, that would be squared. And then remember, we always do plus c. Okay, so that's the first kind, and you'll have about a third of them like that where they tell you what u should equal. Now, when they don't tell you what u should equal, you usually can figure it out not too bad. A lot of times it's just whatever's in the parentheses or whatever's the main part of the problem, but you can usually figure it out or just fiddle around until you do. But on this one, I'm just going to say that u equals x minus 10. And du would then equal, well, the derivative of x is just 1. The derivative of 10 is 0. And so that's really just dx. And then again, we've got to come over here and make sure we've got everything accounted for. And my biggest problem is actually right here, because I don't have anything to make that x, because remember, everything's got to turn into u's. Everything does. Well, that's going to have to come from right here. I'm just going to have to rearrange this a little bit, add that 10 to the other side, and say x equals u plus 10. Because now I can turn everything into something. So now x would be u plus 10, and then x minus 10 is u to the 7th, and then dx is just du. So everything turned into something, and that's a really, really important part of this, is that you're not just guessing, that you're looking and that you actually have something for everything to match with. Okay, and then we don't really have a way to integrate two things multiplied together, so I'm going to have to probably distribute this in just to make it easier to work with. So if I distribute u to the 7th, it would be u to the 8th plus 10u to the 7th du, and now I'm ready to do my power rule. So increase by 1, divide by that power, increase by 1, divide by that power, And then I'm going to substitute that back in. So u turns into x minus 10. So that would be, oops, not u anymore. That would be x minus 10 to the 9th over 9. I'd probably reduce that to 5/4. So 5 times x minus 10 to the 8th over 4. And then don't forget your constant. Okay, not too bad. And then the last third is trig, which shouldn't be too scary. As long as you are pretty good with your trig rules, you should see stuff that helps. It doesn't bother me at all that we have a secant and a tangent, because remember that the derivative of secant is secant tangent, so that's no big deal. So I'm just going to make u equal this, because notice it's the same. Okay, so that's where I'm going to head first. So u equals 3x cubed minus 2x. Then always do the derivative next. So that would be 9x squared minus 2 dx. And then remember the little game you play. You've got to look over there and make sure that you have something to match up with everything. And this is causing us just a little bit of a problem. This is like close. It's not quite there. It looks like I need to multiply by -4. So if I multiply by -4, then that turns into a -36x squared and a +8 dx. And now those do match. Okay, so now that's taken care of. And then secant and u and tangent and u, and then I've got my du. Okay, so I'm ready to substitute. So this and this turn into -4 du. So I'm going to have a -4 on the outside, and then I'm going to have a du over here, and then I'm going to have secant u and tangent u and du. And again, hopefully you kind of saw from the beginning that that secant tangent was heading towards secant anyway. And so when I integrate, it would just be -4 secant u. And then that's going to be, substituting this back in, 3x cubed minus 2x, and then don't forget your constant. And that's it. That's about how those work. And so I think as long as you always go to the side and take a little bit of time to do that part right, and then just match everything up, it should go pretty well for you. And that is the end of week 10. Sure hope that helps.